Hello everyone, this is Dr. Bahrami with the short lecture on graph theory in operations research. In this talk, I'm going to talk about graph definition, and then I will go through the implementation of graph theory, particularly minimal spanning tree in operations research. Let's start with graphs. What does it mean? So the graph is ordered triple NAG, where N is a non-empty set of nodes, vertices, A is a set of arcs or edges, and G is a function associating with each arc A, and an ordered pair XY of nodes called the endpoints of A. For example, in this graph that you can see, we have 5 vertices and 6 arcs. So according to the G associating G function here, we are saying that, okay, for example, GA1 is 1 and 2, which means that arc A1 connects 2 vertices, 1 and 2. Here, from this original graph, we can construct a subgraph. For example, by eliminating A4, A3, and A2, and also vertex 5, we have a subgraph. This type of subgraph, we can call it tree. So we are going to use tree in the application that I want to demonstrate. So implementation of minimal spanning tree in operations research. Let's consider an example. A company plans to build a communication network connecting its 5 computer centers. Any pair of these centers can be linked with a leased telephone line. Now the question is that, which links should be made to ensure that there is a path between any 2 computer centers so that the total cost of the network is minimized. So here we have 5 centers, and the ideal way is that to connect each center to other centers. So since we have 5, and maybe it is feasible to do it, but imagine we have a big country, for example, Russia, with thousands of cities and airports. And there's a airline wants to have a flight to all of these cities. And from each point, from each city to another point. So it is not feasible to construct such a map or construct such routes for them, but they can solve this problem. Also here. So we can use the weighted graph as shown here, right? And how we can solve? We can solve this problem by finding a spanning tree so that the sum of weights of arcs or edges be minimized. Such spanning tree, we call it minimum spanning tree. So what does it mean? So let's have a definition here. A minimum spanning tree in a connected weighted graph is a spanning tree that has the smallest possible sum of weights of its edges. You may ask yourself, what is a spanning tree? So spanning tree is a subgraph of the original one. So a tree containing every vertex of G. So by this means we have a connection, we have a reachability from any point to another point. To construct such a spanning tree, there exists a lot of algorithms. So here I'm particularly talking about Prim's algorithm, how it works. We start by choosing any edge with the smallest weight. Any edge with the smallest weight. Then we add to the 3 edges of minimum weight that are incident to a vertex already in tree. Under one condition, never forming a simple circuit. And when will stop? Stop when all vertices have been added. Let's have an example here to demonstrate the algorithm. So we have a graph and we want to find a minimum spanning tree using the Prim's algorithm. So we start with the minimum edge. So as you can see, there are 3 edges with the weight of 1. So we are free to choose one of them. So let's choose BF. Now, in the BF, we are looking to the neighbors. So neighbors are BC, AB, FG, FE, and FJ. We are looking for the smallest. So here we have 2 edges with weight 2. So one of them we are choosing, it doesn't matter. So we choose this one. Now we add a new neighbor, which is AE. Again, in the neighbors, we are searching for the smallest one, which is a 2. And then now we have a new neighbors. So let's choose one of them. As you can see, there are edges with 3. So it doesn't matter which one you're choosing because we are coming back again into these neighbors. So we vast like this. And for example, here, so from point C, imagine it's not 1, it is 3, for example. So which one we should choose? Can we go to the B? No, because the condition said that never create a simple circle. So if we are coming to this B, so we are creating a circle. So it's not allowed. So we are choosing D. And we continue like that. And in general, we can write that this procedure on the table, and we can say that the minimum weight of this spanning tree is 24. So these 24 units is maybe it's like a destination, it can be cost or time. So what we have learned today, so we learned about graph definition, and we saw how we can use the graph theory. For example, in this case, we have a minimal spanning tree in the operations research. We should mention that graph theory is not just a branch of mathematics, but it is also as a systematic tools in operations research. Thank you for your attention.